In this video, we're integrating the inverse sine of t divided by the square root of 1 minus t squared. And it's critical here to realize that 1 over the square root of 1 minus t squared is the derivative of the inverse sine of t. So just a little reminder here. So anytime you're looking at a composite function in an integral sitting right next to the derivative of its interior, you can recognize the chain rule backwards, or alternatively, you could do an explicit u-substitution. So I'm going to highlight this by rewriting the integral as 1 over the square root of 1 minus t squared. That's the derivative of the inverse sine function, sitting right next to the inverse sine function. But I'm going to write that as the inverse sine function to the first power. So I have this composite function, the inverse sine function raised to the first power, sitting right next to the derivative of the interior. That allows me to see the chain rule backwards. So my informal approach is to just say, now I see how the chain rule is working backwards. I add 1 to the exponent of this inverse sine function, and I get inverse sine of t all squared divided by that resulting exponent of 2 plus c, and we're done. And we should check at least mentally here that it works out when I apply the chain rule by differentiating this result. So if I differentiate this, I would bring down the factor of 2 out in front, canceling the 2 in the denominator. And that's differentiating this thing with respect to the interior function, which is the inverse sine. So that gives me an inverse sine of t. And then the chain rule tacks on a derivative of the interior function, and that's the 1 over square root 1 minus t squared. And we see that our antiderivative is correct. Now, if I want to do this in a more formal way, I can use an explicit u-substitution. But I still have to recognize which function is the interior function, and then which piece of this integrand is the derivative of that. And that informs my choice of u. So I'm letting u be inverse sine of t, and that means du is the derivative of that times dt. So I have a 1 over square roots 1 minus t squared dt. And then I transform my integral, and I see that the inverse sine can be replaced with a u. And then I have a 1 over square root 1 minus t squared dt, which can be replaced with a du. And now I apply the power rule to this, and I get u squared over 2 plus c. And then I replace u with this definition in terms of t, and I have the inverse sine of t all squared over 2 plus c. So we get to the same place. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.